trigonometry today, so keep in mind for lesson 11.1, right triangle trigonometric functions, we are going to be using sine, cosine, and tangent. So if you do want to pull up Desmos on your phone or pull out your scientific calculator, we are going to be doing that towards the end of the lesson. So I just want to put that out there. And make sure you're in degree mode if you're using a calculator. All right. So first thing I just want to address with you all is the basics for trigonometry. The most important formula that you all really know pretty well usually is Pythagorean theorem. Pythagorean theorem is a formula that allows us to find the missing side of a right triangle. Now, can Pythagorean theorem be used for triangles that are not right triangles? Mm-mm. Nope. No. So the main thing you have to know about this formula is it can only be used if the triangle is a right triangle, okay? So keep that in mind. If the triangle is not right, you cannot use this formula. There is a formula, two formulas called law of sine and law of cosines, which we can use on any, but we're not going to get into that today. I do want you to know it exists, though. So anyways, let's go ahead and talk about sine, cosine, and tangent. You all know that the ratio for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So those are ones that you learned back in geometry, correct? But the ones you haven't learned is cosecant, secant, and cotangent. These are what we call the reciprocal trigonometric functions, but they are very easy because you're going to notice that they're just the reciprocals of the respective functions here. So you see how cosecant, what'd you say? Yeah, well, I don't want to say inverse. Yeah, flipped. Yeah, because inverse in math means something a little different. So reciprocal means that we basically just flip the fraction. So do you see how all the fractions are just flipped there? So yeah, that's really all you have to know about them thus far. So first thing we're going to do is we're going to solve a missing triangle, okay? So the first thing you have to do this, to identify the trigonometric ratios for a triangle, is you have to first have all three sides. As you can see, we're missing a side here, so we're going to have to use Pythagorean theorem. Good. So the hypotenuse has to be c, or the one over here. So it's going to be x squared, x being the side I'm missing, plus 9 squared equals 41 squared. Now, could I have put 41 on the left side instead? Would that have mattered? Yeah, because hypotenuse has to be the one on its own, right? So remember, hypotenuse has to be the one it's equal to. So I subtract 81 on both sides. I get x squared equals 16,000. And then I take the square root of both sides. X equals 40. So I just used Pythagorean theorem to find 40. Now that I know that, I'm ready to identify my trigonometric ratios. So you always reference the angle that is given to you, theta in this case, and that's going to be like the position that you look from. So as you can see, this side is opposite, right? This side here is adjacent to theta, and this side is the hypotenuse. You can always find the hypotenuse because it's always directly across from the right angle. Does that make sense? So we know that sine is opposite over hypotenuse. We know that cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Now, the reciprocal functions are, you simply just flip each one of these. So you just flip the fraction, and they are their reciprocal pairs, okay? So does anyone have any questions about this so far? Okay. So take a minute, get it down if you need to, and then we'll move on to the second right away. You see that we're missing what side of the triangle in this case? Hypotenuse. The hypotenuse. So you can use, of course, Pythagorean theorem, but I want you to think even more so. Does anyone remember a special triangle, 3, 4, 5? So yes, if you wanted to, you could have found this using Pythagorean theorem. Okay, 3 squared plus 4 squared equals x squared. But this is what we call a special right triangle. Do you guys remember using 3, 4, 5 triangles a little bit? Alright, so we got to save ourselves a little bit of work. Now I'm looking at theta as my reference angle. This is opposite. this is hypotenuse, and this is adjacent. So is anybody struggling with how to identify these things at all? Okay. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent. And then all of these are just the reciprocals. So do we have any questions so far on identifying trigonometric ratios using a triangle?
So how did you find the 5?
I just know this one's 5, but if you wanted to find it, you would just do Pythagorean theorem and solve that, and that will give you 5. Okay? All right. So now we're going to work backwards. So there are times, and here's the thing I want to point out to you guys just for clarity purposes. They will give you these 6 trigonometric functions. They'll give you just cosine. Like a problem could simply just say this, like on an SAT. They could just say cosine of theta is equal to 2 over 3. Find cotan or find cosecant. They don't have to give you all this context around it. Okay, so I just want you to understand that I'm putting the context there because we're in the situation where we're doing it, but you don't need all this other context. They might not even draw the triangle for you. Sometimes you're gonna have to sketch your own triangle. Okay. So they give you one trig function. Now something you need to know is you only need one trig function to find all of them. If you know one, you know them all. Well, theoretically, you have to find them all. But first thing you do is you find out what is cosine. It's what over what? Adjacent over? Good. Hang on, let me get the phone. So, adjacent over hypotenuse. So, as we can see, the angle's right here. This is my adjacent side, right? Which is 2. This right here is my hypotenuse, which means the last one is opposite, right?
Yeah.
We don't know what opposite is yet, so we have to find it. If we know 2 sides of a right triangle, can we find the third? What do we use? Pythagorean theorem. The hypotenuse has to be the one on its own side. Remember that. So we got 4 plus x squared equals 9. I subtract 4 on both sides, I get x equals 5. What do I do next? Take the square root. X equals radical 5. Now, mathematically, radical 5, if you were to put it in a calculator, I don't know what it is, but I can check. It's approximately 2.2. But we don't usually simplify it like that. We just leave it as the simplified radical version, which is radical 5. So now we can set up our trigonometric ratios. We know that sine is opposite over hypotenuse. And we know that tan is opposite over adjacent, right? And then I can find the reciprocals by just simply taking the reciprocal. Now, one thing you are going to notice that will come up is we technically end up with 2 radicals in the denominator. Now, mathematically, this is 100% accurate, but do you guys remember the process of rationalization to get the radical out of the denominator? So I'm just going to quickly remind you about that. So say that you're on a test and you get your answer for cosecant to be 3 over radical 5. You know you did the math right, you checked your work several times, but none of this, the answer choices are this. What could have been the case is they rationalized your answer. What that means is they simply multiply the top and bottom by the denominator's radical. Now we know that 3 times radical 5 is simply 3 radical 5, and there's no simplifying that. We know that any radical times itself is just what's inside the radical. Now if this number on the numerator was divisible by 5, you could simplify it. Like if the 3 was a 10, it would be 2 radical 5. But this would be what we call the rationalized version. Okay? So I'm not going to necessarily rationalize every problem that we do today. I will write the rationalized version. I just want to explain to you how these are equivalent. Okay, because oftentimes they will write your final answer in rationalized form. So do we have any questions about rationalization? Okay. So for the next question, first thing we want to do is identify what cosecant is. We know that sine is opposite over hypotenuse, which means cosecant is hypotenuse over opposite. Now that we know what h and o are numerically, we can put them into the triangle. So our hypotenuse is 17, and our opposite is 8. Which means we can find the third side using Pythagorean theorem. Now this is a more unknown special triangle, but this is actually 15. So there's a triangle called the 8, 15, 17 triangle. But say you didn't know that, feel free to use Pythagorean theorem like we did in the previous step. The math will be exactly the same. Okay? So now we have the information sufficient to solve the rest of my trigonometric ratios. So that's just going to be 8 over 17. Cosine is going to be 15 over 17, which means secant is 17 over 15. And tan is going to be 8 over 15, or 15 over 8 for cotangent. So do we have any questions about how I got these ratios? Okay. Take a second to get it down. Let me know when you're ready. So next question we're going to look at, or concept, are special right triangles. So how many of you in here remember 30, 60, 90 from geometry? All right, so a fair amount of you, so it's not totally like brand new, right? So you probably remember the formula h equals 2 times s and L equals s times radical 3. Ring a bell? We're going to do it a little bit differently in this class just because, you know, we're going to do it a little bit more simplified way, all right? So here's the main thing you need to know. The side across from 30 degrees is going to be A. It's going to be your shortest leg. The side across from 60 is going to be A radical 3. And the side across from the 90 degree is going to be your hypotenuse, which is 2A. So A represents a length. You need a pass, yeah, of course. So A represents a specific length of the side. So the other sides are always in relation to that A, okay? So let's go ahead and look at the other special triangle. Do you remember 45, 45, 90 as well? 45, 45, 90 is a special triangle because it is a right, not equilateral, not scalene, it's a right isosceles, good, because these two sides are congruent. So every single right isosceles triangle will always have the degree measures of 45, 45, 90. So the legs are both A, and the hypotenuse is A radical 2. So what that means is if the legs are like each 4, the hypotenuse is 4 radical 2. Okay. So let's apply these concepts to a few problems. So the first one we're going to look at is a 30, 60, 90. If you want to fill in that missing angle, feel free to do so. Because remember, triangles have to add up to 180, so we can always find a missing third angle in a triangle. So first thing I do is I identify the side that they give me as is it the short leg, long leg, or hypotenuse? Good. So once you identify what type of leg it is, you're going to set it equal to its formula. So in this case, I'm going to set it equal to 2A. So 8 equals 2A, like that. Which means A is equal to what? 4. So now that I know what A is, I know my shortest leg is just 4, which is this one. And I know that my long leg is 4 times radical 3, right? So it's just 4 and 4 radical 3. So does anyone have any questions about how I identified X and Y? All right. Now we're going to do the next one, which is going to be another 30, 60, 90. So on this one here, this is my 30, right? This side is associated with my 60, and then the side they give me is is it long leg, short leg, or hypotenuse? They give me the hypotenuse, so I can set it equal to its formula, which is 2A, which means A is equal to 7. So my short leg is 7, and my long leg is 7 radical 3. You guys get the gist of it?
I have a question. Why is it radical 3?
Because the formula says to find the longest leg, we take whatever A is and we multiply it by radical 3.
Okay.
Anyone else? Okay. Now we're going to look at a 45, 45, 90. Now, we know that these are both the legs, and both the legs must be equal, congruent, however you want to say it. So x has to be 10 as well. So I know 10 is my a, right? So in this case, this is my hypotenuse. We know my hypotenuse is a times radical 2. You see based on the formula here. So does anyone have any questions about that? Okay. Now we're going to talk about trigonometric values for special angles. So this is something that is a little bit new to you guys. So in geometry, you're used to me giving you sine of 30 and you calculate that in the calculator. But there are some trig values that we use so often that we actually have them memorized. And they actually have a very special, specific value. So in the calculator, if you have one, go ahead and do sine of 30 degrees. Tell me what you get. 0.5, which is 1/2, right? I'm going to show you why that is, okay? And then you're going to notice if you did sine of 60, you're going to get 0.866, I think it is, because that's radical 3 over 2. So I'm going to show you the reason behind why those things exist that way, all right? So you probably are wondering, like, you might wonder, where did that number even come from? Like, did you really understand where it comes from? Let's talk about it. So we have these things called unit circles in trigonometry. We're going to get into that in the next few weeks. But in those circles, we had these inscribed triangles, okay? And these inscribed triangles are basically making up, like, one of the pieces sides is a radius of that circle. So here's how we come up with the trigonometric exact values. You first find the smallest side of the particular triangle you're dealing with. Would you all agree that it's this side over here? How did I know that? Because it's across from the smallest angle. So the smallest side you're always going to call by 1, okay? Now from here you apply the rules of a 30, 60, 90 triangle. If this is A, which we've identified, you know, the side opposite 30 is A, that means that this side must be A times radical 3, and the hypotenuse must be A times 2, which makes it 2. And then keep in mind, 1 radical 3 is the same thing as just radical 3. And then over here, same idea applies. Now, our two smallest sides are actually congruent, right? These are the two smallest sides, and they're equal, and they're both going to be 1. Which means that if these are A, then this side must be A times radical 2. So now I'm going to show you how we come up with the sine, cosine, all those exact values based on this. So we're going to treat each of these angles as theta. So first thing we're going to look at is we're going to pretend that theta is 30. So obviously I'm going to be looking at this triangle because it has 30. This is going to be my theta, okay? Now we know that sine is what over what?
Opposite over hypotenuse.
Opposite over hypotenuse. So it's going to be 1 over 2. You see that? Where that comes from? Opposite hypotenuse, okay? Now we're going to do the same thing for cosine. Cosine is going to be adjacent over hypotenuse. That's where the 0.866 comes from, because that's 0.866. Now we're going to skip the 40. We're going to go to 60 first. Okay, so we're going to work with the same triangle again. So for 60, we're going to look at this as our theta. So now we're looking at it from a different perspective. Okay, now this is my opposite, right? And my hypotenuse stays the same. Now for cosine, this is my adjacent from 60, and this is my hypotenuse. If you do in the calculator cosine of 60, you're going to get 0.5 or 1/2. Okay, that's why. So cosine and sine, do you guys see that relationship there? See how they're flips of each other? It's going to happen a lot. Now we're going to look at our 45 triangle. Oh wait, we didn't do the tans. I forgot about the tans. Maybe we should do tans. So for tan of 30, that's going to be opposite over adjacent. And for tan of 60, opposite over adjacent, which is just over 1, which is just radical 3. Alright, so let's go ahead and do our 45s. So for our 45, we're looking at, does it matter which of these two 45s I'm looking at it from the perspective of? No, because they're the same. So you pick one. So I have opposite over hypotenuse. Okay. Then again, I have opposite over adjacent over hypotenuse. Adjacent over hypotenuse. And then I have opposite over adjacent, which is just 1 over 1, which is just 1. So you're never going to really be asked to reproduce this table. It's just that I want you to understand where these values come from. This is more of an understanding piece of the notes, more so than you have to do this on your own type thing. So now that we have this, I want to look at this table. What are these? What do we call these again? They start with an R.
Reciprocal.
The reciprocal trig functions. And we know that cosecant and sine are reciprocals. We know that cosine and secant are reciprocals. And finally, tan and cotan are reciprocals as well, correct? So, all we have to do is take each one of these values and take the reciprocal of them. So what's the reciprocal of 1/2? 2 over 1, which is just 2. And then we have radical, or 2 over radical 3, regular radical 3. The reciprocal of 1 is just 1. This is radical 2, 2 over radical 3, 2, and 1 over radical 3. So you see how I just took each box and flipped the fraction. Everybody see how I got that? Now keep in mind as well, a lot of these are not rationalized. So oftentimes, you will see them write this as radical 2 over 2. I just want you to be aware that those are equivalent. Okay, that's its rationalized form, for example. Any questions about that? Okay. So now we're going to use our skills and knowledge about triangles to figure these problems out. So there are 2 types of questions they can ask you that require you to use sine, cosine, tangent in your calculator. They will give you an angle and a side and ask you to find one of the missing sides, or they will give you 2 sides and ask you to find a missing angle. When you have the angle, you always use the regular trig function. So the first thing you do is you identify the angle and you treat it like theta. You look at the side that you know and label it, in this case opposite, and then the side that you want to know and label it. What trig function involves opposite and hypotenuse? Sine, cosine, or tangent?
Sine?
Good. So sine of 24 is equal to opposite over hypotenuse. Can I put this over 1 and then I can? Cross. Good. That gives me 11 equals x times sine of 24. And how would I then solve for x? Divide by sine of 24, right? That gives me x equals. And then you just do this in the calculator. So I go here on my Desmos, okay, clear it out, and on Desmos I have this sine button. I type sine of 24 divided by, oh wait, it's 11 over 70, other way around. So I have 11 over sine of 24. So it looks like that, and you should get approximately 27. Next one, I have my angle here. The side I know is the hypotenuse, and the side I want to know is the adjacent, correct? So what trig function am I going to use here? Cosine. So cosine of 70 degrees is equal to adjacent over hypotenuse. If I put this over 1 and cross multiply, I get x equals 15 times cosine of 70, right? So to get my actual answer, I'm going to have to use a calculator. Oops, sorry. So I click on my calculator, I clear it out, I type 15 times cosine of 70. And you should get about 5. This one, This is opposite. This is adjacent, so I'm going to use the only one left that we haven't used yet, tan. Tan of 52 is equal to adjacent over opposite. Oh wait, I did it backwards, didn't I? I'm thinking cotan. It's opposite over adjacent. Cross multiply. That gives me x equals 6 times tan, right? Clear it out. 6 times tan of 52 is approximately 7.7. Alright, so do you remember doing this back in geometry?
Yeah.
Okay, so nothing new. We have one more thing to talk about. So do you guys remember using that second button on the calculator, having to do second cosine, second tan? Let's talk about when we do that. So, these ones are actually easier than the previous. What do you notice looks different about this problem than the prior? We're missing what instead of what? We're missing an angle instead of a side. So when you're missing an angle instead of a side, however you want to write this, remember it, whatever you want to do, you always use the inverse. When you're missing an angle, you use the inverse. So in this case, the sides I do have are opposite and hypotenuse. Would you all agree with that? So here's how you do it. Since it's opposite and hypotenuse, I have to use sine inverse. So sine inverse of opposite over hypotenuse is equal to x. So in your calculator, you're going to do sine inverse 6 divided by 14. So if you're going to be using Desmos, here's how you do it. What's the problem here? Do I have the right buttons I need over here? Do I have a sine inverse here?
No.
No. So if I click function, you see now I have the sine inverse button. And then I can do 6 divided by 14, which gives me the angle measure of approximately 25 degrees. So it's pretty straightforward. Why don't you guys try B and C on your own, so I'm not just talking at you for the rest of the period. Go ahead and try B and C on your own. I'll put the answers up in a few minutes. And then you can start working on your homework when you're done with those. Okay? So they're pretty easy. I'll put the answers up just to make sure you guys have it. So those are the answers to B and C. Any questions about those?
How'd you know it was cosine for B?
I knew it was cosine because do you see how the opposite side would be that one that's vertical? If I don't know the opposite side, the only trig function I can use has to be cosine because the other two require opposite.